As I was so kindly introduced, my name is John Coggeshall. So a little bit about kind of the little background about what all the little spiel is about. So I wrote the tidy extension for PHP 5 and still maintain it, although it seems to be pretty bug free. So I say that it's perfect code. Back when I worked for Zend Technologies, I was the senior architect for the global services group. So basically, what my job was basically everything in the company. So it was a consulting arm of Zend. So Zend has its products and its services and things like that. And when we had a customer, and it was almost never like related to product. It was, we had a customer and they couldn't build, their site was falling over because they were having too much traffic, or they were concerned about security or things like that. They would send somebody like me or somebody from my team over on site, or maybe just remote or something, and we would either train or fix the problem or say you're really screwed. I could tell you all sorts of stories from my time there. My very first project working as a senior architect for the global services group was working for a company called Signature Networks. They've since been acquired by Live Nation, which is the ticketing company, the huge conglomerate ticketing company now. But back then, Signature Networks had a kind of a white label online store for big bands. So for example, you would have like Britney Spears. And that was one of their customers. And you could buy all sorts of merchandise about Britney Spears through their site. And so they had landed this great contract, U2, this huge band. And U2 wanted everything different. So they started trying to scaffold on all these new features like forums and this and that to their kind of really old kludgy. Who was that? You guys were at the keynote? Like all the stuff that Laura said was a really bad idea. That's what they were doing. And so we were brought in to try to help with this, and I'm halfway proud to say now that I've survived it. That very first kind of professional gig at Zend Technologies ended with Bono publicly apologizing for how bad the site was. It wasn't our fault, but it was an interesting experience. And I'm also, of course, a Zend Framework contributor. So I was around back when Zend Framework was just kind of a gleam in Andy Gutman's eye. He's like, I want to do this framework thing. I think that'd be really good. PHP really needs this. And so I helped kind of with I reviewed the initial architecture documents, things like that. I wrote a number of components for ZF1 when I worked for Zend. And of course, I'm pretty adept at ZF2 as well. So getting on to ZF2. This is going to be a very code-heavy talk, like I said. If you want to see code, all this code is eventually going to be made public on GitHub. We're going to be looking at two separate projects. One of them is a little sample application that I'm actually using for my next talk, which is virtualization for developers, and that's written in ZF2. And the other one is actually a Google Glass framework that I'm going to be releasing in the next week or so to build Google Glass apps using PHP. And so the Google Glass one is a lot more intricate. So if you guys have some like kind of crazy questions about, well, how do I do something like this or that? Chances are the Google Glass app we can walk through, and I'll show you how that kind of wiring works and how those things work. But we may just stay with the virtualization demo app, and that's already on GitHub. So if you guys can't see code too clearly, you can always just pull the code down from there and check it out yourself. So what are we going to look at here? Well, we're going to look at 4 kind of key concepts when it comes to Zend Framework 2. The first thing, the model view controller architecture. Chances are everyone in this room probably already knows what MVC is. I assume you do. The second thing is just the modular approach that Zend Framework 2 has. And that's going to tie directly into the last two, which is the service manager and the event manager. Because those two components are a little weird for a PHP developer to wrap their head around. They have a lot to do with like dependency injection and decoupling of things, and that's why it ties directly into the module architecture. So getting started with ZF2. The best way to get started with a Zend Framework 2 application is just go download the skeleton app. So there's a composer package. You can just say create project. Here's a little command. And Zend Framework has this skeleton thing that's in GitHub. that's like basically an application in a box, and it's got all the directory structure set up, it's got basic controllers, it's got all these sorts of things that you're going to need. And you can just kind of point document root at it, and voila, you've got an app. And that's how you should probably always start your applications, because it's always going to look the same off the bat, and so it's just a lot easier to go down that road. There is some tooling also available. There's a tool called ZF tool, which allows you, just kind of like with Ruby, one of the big things, going back to Laura and her talk, with Ruby was that, oh my God, there's all these great tools that I can use. And these tools allow me to do things like, just create controllers and create models and all this stub code. And then I can just kind of tweak it as necessary, and it allows me to build my apps real fast. ZF2 has the same thing, ZF2 has the same thing called ZF tool. Which you can also just download. It's a FAR package, and you can just run it to create some of these things. I'm not going to do that. I don't like doing that. I don't like generated code because I always end up regretting it later. It always ends up like kind of code blue. But it's there if you want it. So let's talk a little bit about the basic ZF2 file structure. So when you go off and you get the skeleton application, you're going to have a whole bunch of directories and a whole bunch of stuff. And there's really basically 3 directories that you're going to care about off the bat. Okay? The first one is just going to be the public directory. That's your document root. So in there, you're going to find a lone index.php file, which is going to bootstrap your application and load it off into the MVC for PR for Zend Framework. It's where you put your images, your CSS files, all that sort of good stuff. Then you're going to have your config directory, which is going to allow you to specify all your different configurations. And we're going to talk about that in a little more detail, because configurations in ZF is kind of one of those key technologies, I guess, because it ties right into the way modules work, everything else. One of the cool things about just the way ZF did it, which was really clever, is that basically the config directory is just going to be a bunch of .php files, and they're all going to return an array. And those array keys are the configuration values, things like that. And we'll look at that code. But the cool thing is that it has this notion of global, local variable, or local configs and stuff. So you can have, like, for example, say you have a local development environment, you have a different username and password for your database. You can have database.local.php and then just database.php, where database.php defines some of the properties, like the host name or the database name itself, things like that. And then the local one has the username and password. And by default, that stuff never committed to Git. So that way you can kind of keep things segmented and have like a local configuration without clubbing somebody else's configuration, things like that. But ZF2 is all about modules. So everything in ZF2 is a module, at least to you guys. If you get into the lower level PHP stuff itself, or lower library stuff for ZF2 itself, obviously there is a framework underneath it, but for everything that you guys will ever do with ZF2, you're going to probably create a module to do it. That's the application, that's the stuff the application uses, and so it's a really kind of core concept. And modules basically fall into one or two categories, right? They're either a module that is kind of general purpose, so you'll see in my virtualization code base, I've got a Twilo module that I wrote that allows me to interact with sending and receiving SMS messages through their API. And that's kind of a generic purpose module that eventually, once I'm happy with it, I'll put on GitHub. And then you can just add that to your composer and say composer require Coggeshall/Twilo, and then you'll have that in your vendor directory. Or modules can actually be kind of much more application specific and just used as a way of dividing up your code. It really depends on the needs of your application. But we'll, like I said, we're going to get into all of this. And so how do modules work? Well, modules basically work, like I said, we're going to look at all this code, so don't feel like this is a little overwhelming. Oh, thank you. I was looking for that. Hold on a second. My clock is not cooperating. So when you look at a module, basically it's just a kind of standardized directory structure. It has its own namespace. And it all starts with a module.php file in the root directory, and that's what we load up. And there's a bunch of callbacks in there that let you bootstrap different stuff. And it's all basically about kind of creating things for the service manager, creating things for the event manager, and creating some configuration. And that's basically what modules do, and that's kind of how you tie the modules into the rest of the application as a whole. Creating routes, things like that. And like I said, modules have their own configuration that can be overridden. So module configurations or configurations in general in ZF2 are hierarchical. So they're very simple. I mean, they're just, you literally just say return array. But if you have a key foo at the root of that array in your module, and then down the line in your application, in your local configuration, you have foo equals bar, that's going to trump whatever came before it. So you kind of build these kind of hierarchical structures, and it's convention versus kind of like forcing it down your throat, you know? And you'll see a lot of that in ZF2. There's a lot of things here, and I think that's one of the biggest things that confuses people up front. So they're like, where did that come from? Like, why is that called that? And I don't understand how that's defined, and it's because we made it up. It's just like an arbitrary handle to something, and so once you get your head around that, you start going, oh, okay, I get it. That makes a lot more sense now. Because some of the handles, they look like class names, but then you can't find the class, and you're just really confused. So modules can have are themselves fully kind of encapsulated applications. Like I said, an application, ZF2 starts with a module. So routes, controllers, models, database access, whatever you want, you can have in that module, and different modules can have their own routes and their own things and all that sort of stuff. And the modules can mess with each other through configuration, especially if you build your modules right. You kind of give these little hooks into them where, you know, I don't like the way that route is. I want to change that route, you know, and so you can create these different routes and change the way the paths work and all that sort of stuff. So modules. There's a few different, I don't think this is an exhaustive list. This is probably the most common list of things in your module class. And like I said, we're going to look at this code too. But these are different callbacks that happen when a module is loaded into ZF2. And loading into ZF2, you'll see, is just literally adding like one line of code to your array, saying, load this module. So we'll go through these and we'll look at the code behind them as well. Git autoloader config. This is just basically the bootstrapping that's used to actually like load the PHP class file. So when you're looking for namespace foo bar baz and, you know, class whatever, the autoloader config kind of just defines how Zend Framework's loader is going to find that within your code base. If you follow the standard practices and the standard kind of way things are structured, you almost never touch that. That's almost like a copy and paste sort of piece of code. Git service config is an important one that we're going to get into. That's all about the service manager, and you'll see why that's a very important component to pretty much everything you're doing in Zend Framework. This is one that I put on here because doesn't seem to be documented anywhere, but it's actually really kind of important for me because I'm kind of OCD about these things. I want dependencies. I want modules to know that they require other modules. So Git modules dependencies is actually something that does exist. It doesn't appear to be documented, but you can return an array and say, my module requires this module and that module, and then make sure that, you know, these things exist before moving forward. And then on Bootstrap, that's also going to be an important kind of hook for you guys, because especially when we start talking about the event manager, and we start talking about handling events that are coming out of the framework, other modules, all of that stuff kind of gets initialized in your Bootstrap when the module fires up. And that's how it like hooks into other stuff and starts moving forward. So, how modules are structured? Pretty simple. You've got your config, you can have a language directory. Like I said, this is all almost completely arbitrary. Like this is, again, convention versus like forcing it down your throat, but I recommend you kind of try to follow this stuff. You have a source directory and then all your code in there, a view directory and then all your views. Maybe you have, and then you have your module PHP at the bottom. So let's start by really trying to get into this. I don't know, you guys are not going to be able to read that, are you? All right, let's see what we can do here. Hold on. Maybe I can kick up my resolution to something obscene. No, that's not it. Displays. see if that's maybe a little better. All right, we'll kick it down to 1024. We'll go old school. That should be a little better, right? All right, cool. All right. So I'm going to just kind of start by just walking through these things I just kind of told you about and kind of give you an idea about how they're all wired together, and then we'll go from there. So it always makes sense to just start with your index.php file. I'm not going to spend a lot of time on this, but this is a standard generic thing you get from your skeleton. It doesn't do a whole lot. I mean, well, obviously it runs your whole application, but it's pretty simple. ZF2's got a built-in notion for like the CLI server for PHP if you're running like a local PHP web server. Or if you actually want to do like command line code, you use the same MVC architecture. That's kind of out of the scope of this talk. But basically it just says, okay, we're going to take the application, we're going to initialize it with our configuration, and that's going to be whatever that array is, and then we're going to run it. And that's going to be the end of it. That's it. So everything kind of starts with application PHP here. And like I said, all the configurations in or in ZF2 basically run like this. So you just return some array with a bunch of key and values, and depending on what you're returning, it sets up different stuff. So at the beginning there we have our modules. So I've got my two modules. I've got my application module, my Twilio module, and then the module listener. That is a component. You don't really care, honestly, about that. That's kind of like an eternal ZF thing that's for more advanced usage. But you set up stuff like, here are my module paths / vendor for my composer stuff / module for my local modules, my config stuff. So I'm looking for things that have .global or .local in them. And all this stuff, like I said, you're not going to have to screw with most any of the stuff in your application config.php. But it's good to know what it is. The only thing you're really going to care about is you'll probably spend your entire life editing this file and just adding lines to the modules key there, and just like that's your hook to add a new module. And then within the module directory, we've got our application, and then again we've got our config, and we've got our module config. So again, these are all merged together recursively. So when you ultimately think of the configuration of the application, you really do have, like when you go tell Zend Framework using the service manager, and I'll show you how to do this, say, give me the application config. You're getting this giant array that has all of these little config files all squished together and cached. So keep that in mind, and they'll overwrite each other and variables will change and stuff. So, but there are common keys. Like router is one of those keys. And you could have put that router stuff if you wanted to. You could have put that in the application config that I just showed you. But it doesn't necessarily make any sense. Maybe you have a use case for it. But so we have the router. And I'm going to go through the router stuff a little later. But we have the router, which defines the different application routes. And then we have things like the service manager key, which is going to be which is kind of just a separate way of doing what you find in module.php. Like I told you, git service config, that's kind of like the programmatic way of doing this. So this defines various different services that this module can provide. And like I said, we're going to get into this. I want to go through a few more slides before I go back to this. Then translator, this isn't a globalization talk, so I'm not going to talk about the translator. Controllers, setting up the view manager. So it's all basically, I think when you go through this on the skeleton, if you just dig through the code on this part so far, the stuff I'm not explaining you're going to be able to pick up pretty easily. Display not found reason, true. It's not particularly difficult. And then we have our source with our application, and we've got our controllers and all this sort of stuff. So now in module, you can see here where we start kind of doing some various different things. We have our event manager. Well, in this case, I've got my on Bootstrap event, right? And I'm handed an MVC event. And then from there, I do all sorts of stuff from this particular module. In this case, since it's a Twilio thing, I'm creating events. I'm attaching to various different events, creating logic. My git config, I'm returning my configuration. And then my service config here, I'm creating various different services for my service gateway. So, and then of course my git modules dependency down there where I say I'm dependent on Twilio. So let's start trying to get a little more practical about this. Let me see where, now my slides are all messed up. So we're going to start, So before I get too far into Service Manager and events and all that sort of stuff, I want to start off with hopefully letting you guys just walk out of here being able to like write a web page, and not necessarily do anything too crazy. So we're going to start off by just talking about basic MVC stuff, and I'm going to skip over a lot of like the internals about hooking into events and Service Manager and all that sort of stuff, and come back to that afterwards. So MVC, everything in Zend Framework, especially the MVC stuff, is all event driven. So when I do talk about events and stuff, keep that in mind because that's how you change the behavior of the Zend Framework MVC. So there's these 7 different events that get triggered that Zend Framework itself listens to, and your modules can listen to, and anything else can happen. When these get fired, and you can do different stuff. So, for example, when a new module is initialized, the Bootstrap, it's initialized because Zend Framework fired off the Bootstrap event. And there's a module manager that's listening for Bootstrap event, and that goes off and bootstraps all the modules. Dispatch, if you're familiar with Zend Framework 1 or any MVC stuff, that's where you can do stuff. You can hook into that event, and you can kind of short circuit things if you want to. For example, like authentication. Like, oh, the user's not authenticated, so I'm not going to let them go to this controller. I'm going to shove them off somewhere else to get authenticated first. If you want to do error handling, like dispatch errors or rendering errors, all these sorts of things. And these are all part of the Zend MVC event class. So when you attach them, there's a constant for you. Say MVC attached to this particular constant, and here's my closure, or here's my factory that I want you to do something with. For the most part, you don't have to worry about these things. Like I said, it's important conceptually to have them in your head that this is how I would do that. I attach to this event. But for the most part, Zend Framework is just going to magically do this for you. So what you're going to be most concerned about building a Zend Framework app from the start is really more configuration oriented, honestly. It's going to be going back to the config and and we'll go back and we'll talk about routes. Here's how you set up a route. It's important to realize that what's happening is first there is a Bootstrap event, and then so when you go through, first you have the Bootstrap event, and then the router goes off and figures out what the route is, and that fires a dispatch event, and then the dispatcher goes and runs a controller based on what the route figured out, and when the dispatcher's done, it calls the finish event to give any last second changes, and then a render event. Then it says, oh, well, what did I get back from this dispatch? Did I get a response? Did I get a bunch of variables? What did I get? Well, if I got a bunch of variables, I got to render it. So I'm going to fire off a render event, and that's going to call the renderer and actually pull in the templates and let you do stuff there. And then ultimately, I've got a final response object. So the whole thing is kind of encapsulated like that. In comes the thing bootstraps. Your context is set up in this request object. That's passed along with the event and everything else. Ultimately, the output of the entire process is some sort of response object, which then gets returned as the actual response. And that can mean like a JSON response, or it can mean an HTML response. So it's important to keep that in mind. Off the bat though, you're just going to screw around with templates. So you're going to define routes in your application or in a given module. And you're going to say, here's a route, and here's kind of its profile. And Zend Framework has all sorts of different types of routes, literal routes, and we'll talk about some of them. And then those routes map to a controller in action, which gets dispatched, and so on and so forth. So let's look at the routes off the bat here. So I'm going to look at my application module config. And we're going to start off here with just the router key. right here at the top, and then we've got the routes kind of subkey. And then, like I said, different modules, they can all have these keys. So you could have, you know, a router, and in fact, if we look at my Google Glass stuff, you'll see that my Google Glass module needs specific URLs or callbacks and stuff from Google. So I actually define routes in that module that are kind of internal routes that, you know, most people, in fact, the whole point is that nobody's gonna have to care about what they are. But then there are different types of routes, and they're all defined by this type. And so we can kind of, you know, there's two different ways you can kind of go about it. You could say type, and you can give it like a fully qualified class name if you want. Or you can do a shorthand down here. So this literal and that literal are the same thing. And of course, that literally means literal. So when you have your options and you actually specify that route key, that's the actual URL. And it's not with a / after it, not with a, you know, anything else after it. If it's not literally /application enter, it's not going to match that route because it's actually looking for that literal string in the route. And then all routes have this options key, and that options key basically, when you're doing things with routes, I mean, there's all sorts of quirks, and Zend Framework's got a lot of great documentation, so I'm not gonna like bore you with every single option for every single route. But the basic concept is you create a route of a specific type. The route key is gonna have kind of the pattern or whatever, like is it a regular expression or is it, you know, like a segment or whatever it is. Routes can have child routes, so you could have like the application route, and then you can have child routes, which are kind of recursive. It's the exact same thing, just kind of recursively down. And then they all have this like defaults, where like it's like, okay, well, I'm going to define my namespace. If in this route's case, then my default, you know, namespace is application controller, my controller's index, and my action is index. And since there is nothing in this literal route that defines a controller or defines an action, these defaults are basically hard codes, right? It's basically just saying, when I go to /application, I'm hitting index controller index action, because there's nothing that can possibly override that controller. But if you scroll down a little bit here, you see we can define a child route for that /application. And so child routes, again, are literally just a recursion back into the same data structure. So in this case, we're defining a different part of the route, which is the segment. And then that route we define as the controller and optionally the action. So when you take this whole thing as a entire route, what it's saying is you can go to /application and you always hit index index. Or you can hit /application /foo/bar. And it'll take you to the foo controller in the bar action in the application namespace. So you can see how you can kind of build these very complicated routes. And then, so, you know, constraints, and these options vary from route type to route type. So like literal really doesn't have many routes, or make any options, it doesn't make any sense. But segments do. So you can do things like the constraints, like what is that variable, what is the filter that particular thing has to fit in order to be happy. And then we don't define any defaults here, because we're expecting our controller and first off, our namespace was defined by the parent route. If you remember up there, we had our namespace. So we know where we're going generally. And then the controller and the action are key parts of this route. So we define no defaults, because we're going to have those controllers and actions populated for us. Does this make sense so far? Is there any questions about this? Okay. So, all right. So when we ultimately, when we hit our route, we're going to end up in a given controller. And so, like I said, it is arbitrary. You can see in the route where I define the namespace that the namespace is application/controller. I could have done like application/ I don't like the name controller. And as long as I had the directory structure right, it would have been fine. So again, convention over kind of shoving it down your throat. But here I have an index controller in my application controller namespace. There's obviously a base class that you want to extend in some way, shape, or form from Zend Framework itself, which is the abstract action controller. And then you can just define, just like in ZF1, your various different methods, so your index action, your foo action, whatever. And what it returns is going to return basically one of two things. It's either going to return, ultimately it's going to return something called a view model object. And we'll talk about a little magic that happens here, because I'm returning an array, not a view model object. Or it's going to return an actual response object. And so the difference there is important because sometimes you have controllers that don't have views. Or they render something, but it's not really a view rendering, like it's a program that executes and generates some XML document or whatever. By returning a response object, you sort of short circuit that MVC process, because the ultimate result is a response object. So if Zend Framework sees that you gave it a response object back, it's going to just say, oh, I'm done. And here's a response object, and just go dump that to the user and be done. Typically, in a normal web page, you're going to return just a bunch of variables. So Zend Framework's got a little magic here, where what it really wants is it wants a view model object. And that's just basically, and the view model object sets the template. That's where you say what template's going to get rendered, and various different, basically it's the container that you hand to the view, and then the view knows how to render everything it needs to do. Everything it needs to know is in that view model. And so you can, for example, if you want to change the template, if you want to not use the default behavior for how do I render, I don't want to render index/index.phhtml. I want to render index/I like something else.phhtml. What you would do is you would create a view model object, and then you would populate that view model object, and then there's a set template method in there where you actually set what template you want rendered, and then that's what you return. This is kind of a shorthand. So if you return null or you return an array, Zend Framework will assume that you really meant a view object. And so it'll go through and it'll build a view object using this default logic that you're so used to. It's got its basic rules for here's how the template works, and here's where the template's found, and looks at the view stack and all this sort of stuff. It kind of generates the stuff for you automatically, but you can always override. So return a response object, override, skip the view altogether, return a view model object, and have very granular control over what the view is actually going to be and how that's actually going to render. The view itself is actually very complicated. It's really well designed, but it allows, there's different rendering strategies, like am I rendering this as JSON or am I rendering it this, and it's very high. It's actually you could do almost an entire talk on just the view in Zend Framework. So in this case, I'm doing something kind of simple, right? I'm saying user equals this, get service locator, get some key somewhere. And then I'm just saying users equals users touch all. So obviously, I'm listing users somehow. But what really is going on here, and this is going to get us into the service manager, which is one of the coolest things in my mind. When you really get your head around the service manager and how it works, you start feeling like, oh my God, I can finally write code that's actually decoupled, and actually, and I don't have the dependencies are not a problem. So, what is the service manager? The service manager, MVC relied, the entire framework lives and breathes on the service manager stuff. That and the event manager. So the service manager is basically the idea that I'm going to define some random key, some unique identifier. And that unique identifier is going to be a handle to some sort of object. And that could be a database table. It could be like a table gateway component, or it could be whatever. It could, for my Google Glass framework, there's a service manager key that represents the glass service, the thing that actually lets you talk to your glass, or various other things. And that key, I'm going to define, it represents basically some way that I'm going to get this object. And there are lots of different ways I can get that object. There's a notion called invocables. So if you look at the code here, I look at my module config here, you'll note in my controllers here, and actually that's actually really important to talk about too. So all of these things, the view manager, so this key, view manager, the controllers key there, the service manager key, really at the end of the day, these are all service managers. They're the whole thing, every one of these is a service manager. And that's a really important concept because service managers have this notion of hierarchical sort of things. I can create a service manager that is a child of another service manager. So for example, in my Glass code, and I can show you how this works, I create my own service manager that handles retrieving API objects. So if I want to do like an API call to Google or something, I say, get me this key, insert : : list. And that's like the list call or timeline : : list. And that's the list API call object. And that's its own self-contained little service manager, and it has access to every other thing in the general application service manager, but the general application service manager can't get at that pin. And so all of these various different components that I'm talking to you about, these are all service managers. So you'll get weird things where you'll literally say, get service manager or get service locator, and then immediately get service locator again. And people are like, what the heck is that? And it's because in whatever context you're in, you have a service locator, but that's like a very contextual service locator for just the view maybe. So if you want to actually get at your application config, you actually have to get the service locator from that service locator, and then you can get your config or whatever. So, but that said, these configurations, so when I talk about controllers here, this is actually a service manager. So when you see things in service manager, they can apply to controllers and vice versa. It's just a different key. And so one of them is this invocables. And this is the simplest way to use a service manager. And that just basically says, whatever key is here, I just want you to create that object. I can just invoke that object. So it's just like say, like return a new foo or whatever. So in this case, application controller index is my magic key, and that is just going to create me an instance of index controller. So that's the simplest way to go about it. Looking up a little higher, so looking in the actual kind of generic service manager that's available through all of ZF, there's other things you can do. One of them is abstract factories. And so I'm not going to get too deep into the various different types of factories, but there's a million different kind of design patterns you can use. Whatever that key is, you're going to provide, like abstract ones are a little weird, but you have a key generally, and you're saying, I want this object, and then you've got some sort of factory to produce that. So that can be a closure. You can just literally like put a closure in there and say, as long as it returns an instance of something, it's going to be good. You can actually have a separate class, which is a nicer way to do it, that implements an interface called factory interface. And that has one method in it, and I'll show you an example of that. In fact, I'll show you right now about that. So if let's look at a little more complicated example here. We'll look at my Google Glass stuff here. So, so you can see here as part of my config here, this is actually kind of when we talk about modules here. So this is my Google Glass module, right? And I've created my own config key Google Glass, and I just made that up. And so now people can use that. And this is where I store all my local Google Glass various stuff, and auth keys and all this sort of stuff, and how I configure things. And going about it this way is nice because it allows me to I did things slightly different for Google Glass, but I'll show you how that works. It allows me to, everything like from my HTTP client. Like how many people have been annoyed, like they've got API library and like the timeout on the HTTP client was like 5 seconds, right? And the only way to fix it is to literally hack the library, right? So now and it just gives you that dirty feeling where it's just like, now I forked this dude's library to change one value in configuration just to give me a hook into it, right? So this configuration stuff works really well for that sort of stuff. Before I get into the other things here, I want to also talk about aliases. So aliases are literally just kind of like symbolic links with these keys. So when I go down here, if at the bottom I say application controller index, that magic key, I could create an alias and say, well, that actually is this other thing. And so that allows me to always make sure I have some sort of handle to my original intent, even if somebody else has overridden that. You know, because I could change, some module could rewrite what application controller index is and make it point to something else or a different controller or a different whatever, and that's cool. But maybe for whatever reason, it's really important that I know which controller was actually mine. So I create an alias to it, and that alias is, you know, not documented, or it's not like, don't ever touch that, that's my alias. Where sometimes, like, there's a lot of aliases, for example, that Zend Framework creates. Like, config is an alias that points to all this configuration stuff. So you can use the service locator anytime to say git config, and it will give you all this config stuff.
Seems like most of this stuff is pointing to like namespace paths.
Yeah, well, it's by convention. So the left half of this here, like invocables, or when I show you the service manager, this is all made up. I can do whatever the heck I want. This is something more concrete. So if it's invocable, this is actually a class name. But if, like, when I'll show you the service factory, so another way you can go about doing this is actually looking in module, where I look at git service config. So this is just basically, this is a programmatic way to do it, and I could probably put almost all of this in module config, but I just didn't. So one of the other keys that I can return in module config or from here is factories. And here I have all these different Google Glass things that I care about. You know, like the Google Glass API client, and that's my unique path. It's the way I identify what the client service is in my module. And that points to, in this case, it points to an actual class, which is a client factory. So when I look at that client factory, let's see, service, client factory. So I look at the client factory here, and it implements this factory interface as part of the service locator, and that basically forces me to implement this create service method. Now, and this is where this service stuff gets really cool, because you have these factories that produce stuff, and it allows you to inject dependencies very, very transparently and very, very kind of decoupled from everything else. So this class's job is to return a Google client. That's it. That's its job. And this is actually the wrong client factory. Hold on a second. Let me look back. I rewrote this stuff. API. So originally when I was writing this framework for Google Glass stuff, I was using the Google API for PHP library, and that sucks. It's horrible. So I rewrote it. That was the old one. This is the new one. So client factory, I just have this create service. I'm given a service locator, so I have the ability to go pull other stuff out of the void that I want. And in this case, I'm actually, so for the client, I'm actually creating a scoped service manager, right? So I'm creating a new service manager that is a child of the original service manager. And I'm creating a config object, and this is a chunk of code that's not documented at all in ZF, so it's probably worth going over. But this is how you create your own service manager in a way that can inform, this is how Zend Framework does it. So like, if you dug through Zend Framework's code about how does it take your config and actually like create stuff, this is how it works. So we create a scope service manager, and then we create this config, which is, I can't remember. This config object is actually a service manager config object. And we give it an array, or whatever, of key value pairs that are the config. And then this config object has a method called configure service manager. So like, where are these conventions defined? Like, why is it view_manager and service_manager for these configuration keys? That's all defined in configure service manager. So that method's job, if you opened it up, it like said, oh, does this key exist? Oh, okay, well, I'm gonna set the appropriate properties in service manager to reflect this configuration. So by doing it this way, you maintain the exact same look and feel of Zend Framework stuff natively, but kind of in your own service manager. So I create a new client, which in this case is, oh, it's in the same directory, that's why. It's just an API client class. I create a service manager. I configure it all up. I set the service locator for my API client to my newly created service manager, and then I return that API client. So I've done something like I've injected, so when I call, when I say, hey, service locator, get me Google Glass /API/client, it calls this factory, and not only does it give me the client, but it gives me the client with the service locator automatically injected, everything's ready to go, and so now every time I use that object, I'm very confident that I have all of my dependencies resolved. And so you can build off of these things. So if you look at different modules or services, so if we look at, for example, Glass service. So if we look at Google Glass service, right here, yeah, that one, I have a glass service factory. So a little bit about my architecture here. My architecture here, the glass client is one component. That's the part that actually does the talking. It goes off and makes an HTTP request or something. But the thing that users use, like you guys would use, unless you wanted to do something very specific and change stuff, is I have this object glass service, which kind of abstracts away API calls to do real world tasks instead. And so in order for that thing to do its job, it needs the API client. So when I say go give me the glass service, within the factory of that, I tell it to give me the API client, which is the factory that we just looked at. So you can see that one factory will call another factory, and you can build up these things and inject all the dependencies, and ultimately I get my glass service back. But it's got my API client in there. And then if you look at the API client a little closer, there'll be a point in there where it actually loads the config, and then it goes, looks at the config and injects the configuration for the HTTP client that's in the config. It says, okay, well, here's your HTTP client back. And so you can see how these things sort of HTTP like client factory. So here's my Google Glass HTTP client. And here I'm using Service Locator to get an alias config, which is all of my configuration stuff for the entire ball of wax. And then I create just an HTTP client. That's just an HTTP client. And then I set the options to it to whatever my HTTP client keys were for that config in my module config. So this is how I inject, this is how I take what's in module config, right? Which could be just whatever module config is, or it could be overridden in a local configuration file that's in the application. But whatever those values are, when I get an HTTP client, I automatically inject them and automatically kind of prep that object ahead of time. Any questions about this?
Thumbs up, John.
What's up? Oh, geez. Okay. Well, I guess we kind of actually went over all this stuff. Yeah, actually, I think other than not going through the rest of the slides, we kind of went through all these sorts of things. This is like I told myself, I could talk for hours about this stuff. It is a complicated beast. What I will say though is that what's important is with the service manager stuff, really get to know this. I mean, we went over and you can kind of see why. If you have a controller and you have special stuff that the controller needs, I'm using a controller, in the examples I showed you, it was just an invocable, right? Which means it just created the instance. But I could have created a factory for that controller. And that factory or a closure for that controller. And as long as I got a controller object back at the end of the day, nobody cared. But when I created that controller object, it gives me an opportunity to inject those dependencies. So like if you wanted a DB resource in every controller automatically available, you could use a service factory to create that controller inject your database object, using setDB, and then return that controller. So every time that controller is available to you, you always have that dependency on it.
It seems like there's multiple places you kind of define the same thing, so it's. You can do
It is,
you
yeah.
can do it in the module, you can do it in the
Right.
source config.
Right, and that's because some of the stuff, like all the stuff that I have in my Google Glass, like Git service config, could all be a module because they're literally just key value pairs. Like it's just pointing to a factory.
Is there a reason to prefer it over one place
Yes.
over another?
Yes. If you want to have logic, like maybe you want to have logic, like sometimes I want it to be a key just pointing to a factory, and maybe some other times I want to point to a different factory, or like I want to have an if conditional in there or something. You can't do that in the array. So you have actually like a chunk of code where you can kind of dynamically build this thing out to whatever you want and return it. So, but yeah, any other questions? I mean, I'm available afterwards too for all sorts of stuff. Yes?
Are there any benefits to using literal routes as opposed to segments or patterns?
Yeah. Well, I mean, it's verbosity. I mean, like literal routes are going to, they're very unforgiving. It's got to be exactly that route or it doesn't match, which is good sometimes. Segments though are nice because they simplify things. Like you can have a segment where the controller's hard coded but the action's not. So like /foo will take you somewhere else and /bar will take you somewhere else, or regular expressions or whatever. You can also do variables. So like that controller, and that's something I should have probably gone into a little more detail. That when you look at a route, let's see here. Where's my original routes? When you look at a route like this is my Google Glass demo app. So here I have a segment route, and it's /timeline, and then /action/ID. Action ID, these are arbitrary values. They only have meaning depending on like that Zend Framework assigns. So action means something special as Zend Framework. So that's going to define the action that's dispatched. But ID I made up. So like in my controller, I can say like this, get request, get param ID. And it's going to return whatever this value was. So like, that's a good way to do like, show me time on that number one. And then that's how I can pass that variable back and forth. But ultimately, I define my controller and I define my default action here too. So this is a great example of like, by default, the action's indexed, but whatever's up here, whatever comes in the route's control. Any other questions?
So when you look in the big view of everything, you have all these configs, and it ends up being a lot of paths and everything to cache.
Yeah.
The framework itself kind of.
It caches
It knows the framework and it starts the.
It caches all sorts of stuff. Yeah, absolutely. Like the building of that giant config stuff ultimately ends up as just like one giant config that just gets included and updated and stuff. So, well, thank you guys.
Thank you.